Okay, so today we're covering actually two sections of your book, 4.1 to 4.2, and it's going to be plotting and interpreting graphs. Nothing too terribly difficult. All right, so starting off, vocabulary. Quadrant is a big one. A quadrant is one of the four parts into which the axes divide a coordinate plane, labeled 1, 2, 3, and 4. 1, 2, 3, 4. Okay. Now notice those are Roman numerals. They need to stay that way. Another thing I want you to remember is that your y-axis here runs up and down. Your x-axis runs left to right. Okay? So make sure you know that. Now what do we do with this? Okay, let's say I've got those 4 points. Where are they? Well, you always start with your x because we always label our points x, y. So A, if you notice, is 1, 2 over on the x-axis. So that'll be 2. And then 1, 2 up on the y-axis. So that's at 2, 2. B is at negative 4. So there's negative 3, so that's negative 4. And again, we're at negative 2. Or I'm sorry, just 2, positive 2. And then for C, we're at negative 2, negative 3. For D, we're at positive 4, negative 3. And for E, we're at 1, negative 4. Pretty easy stuff. Just remember over here, your points are all going to be positive x, negative y. Over here, you're going to be negative and negative. Over here, they're going to be negative and positive. And over here, everything's going to be positive. Okay? So in this example, where would we plot the following points? Well, just so we're aware, this right here, that's called the point of origin. Okay, so anytime we're talking about graphing, we're talking about from the point of origin. So at 0, 3. So our x is 0, so that means we're right on right here. But then our y is 3, so we have to go up the y-axis. Because remember, it's where these points are on that axis. On the x-axis, we're at 0. And the y, we're at 3. So on where y is 3 is 1, 2, 3, right here. So that's point A. Point B, we're at positive 1, negative 2. So over to 1 and then down 2 because it's negative. And then for C, we're at negative 3. So we go left because it's negative 1, 2, 3. And down 4 because on the y-axis, negative is down. 1, 2, 3, 4. So that's C. Okay, hopefully this is starting to click because I'm pretty sure you guys have done this before. All right, so now let's talk about domain and range. So when you're asked for a domain, it's the lowest x to the highest x, and range is the same but with y. Now the easiest way that I remember this until it became second nature, x comes before y in the alphabet, correct? And we always label our points x, y. Well, domain, which starts with a D, comes before range, which starts with an R. So D comes before R in the alphabet. So D goes with X and R goes with Y. See how that works? All right, so if we were to graph the function, we were asked to graph the function y equals negative 1/2 times x plus 3 with a domain of negative 4, negative 2, 0, 2, and 4, and then identify the range, we would do this. First, you would make a table. 2 columns. Okay, your x, you're going to put your domain starting with your lowest going up to your highest, and then you put your equation that you have. And basically you're just taking this, since this is x, and plugging it in. Since this is x here, we're plugging it in for x down there. So negative 1/2 times negative 4 plus 3 equals 5, which that is, once you get rid of all that, that means that y equals 5. Down here, same thing. We plug in negative 2 for it. We get y equals 4, y equals 3, y equals 2, y equals 1. Okay, now see how that works. Basically, you're taking this number and plugging it in over here where there's an x. So now we have these points. We've got negative 4, positive 5. So that's going to be over here The negative is this way, left, and then up 1, 2, 3, 4, 5. The next one, we're at negative 2, positive 4. Then we're at 0, 3. Then we're at 2, 2. And then we're at 4, 1. Okay? So, and you can see that this forms a nice straight line. I can't guarantee that my line will be as straight, but we'll give it a shot here. All right, so we graphed it. Now, what did I do wrong? Well, it asked to graph the function that with the domain, so they're very specific. So my graph should have actually ended. Let's do this. Change the color of the ink. So I need to make sure those points are on there. And my graph, even though it doesn't look straight, I'm sorry, should be just this part in here without this. Alright, so don't draw the arrows on the end if they ask you to graph it and they give you a domain. It's very important that you don't do that because it's not a line. We were given a very specific set of x's, so we have a very specific set of y's. Alright, so now we get into graphing them ourselves. So, more vocabulary. Solution of an equation in two variables is an ordered pair, x and y, that produces a true statement when the values of x and y are substituted into the equation. In other words, it goes back to what you did earlier. You put in an x and you found out what y is. So when you use that x, you would get that y. It makes it a true statement. Graph of an equation in two variables. It's a set of points in a coordinate plane that represents all solutions of the equation. I touched on this earlier when we were talking about equations and how it relates to graphing. But you'll kind of get the hang of this, the vocabulary and whatnot, and what it means as we go on. And finally, a linear equation. And a linear equation is a graph whose a line. Notice there's line and linear, or you see the line part right there. Okay, so that's your first clue that it's a line. So if we were to graph the equation x plus 4y, now let's change this back to its red so you can see it better. We had to graph it, and we have to solve the equation for y. So the first thing we need to do is put it in slope-intercept form, which is, if you remember correctly, we have that, and then we change it to that by subtracting x from both sides. All right, step 2, make a table. Okay, choose a few values for x and find the values for y with that. So, if we have the equation, y equals 4 minus x. 4 minus x, so now I'm going to use this. So I'll have 4 minus negative 2. Don't forget, two negatives equal a positive. So that equals 6. Okay, do the same thing as you go down. 4 minus negative 1. Okay, which is actually 4 plus 1, which equals 5. And I'm starting to see a pattern here, but let's see if I'm right. 4 minus 0, which is just 4. Okay, so notice how these are going down by 1 each time. So you can check your math, and you'll find that you come up with this. So we've got this table now. What do we do with it? Well, we've got an x and a y that match. We have 5 pairs of them, in fact. So we've got these 5 points. Now we just need to graph them. So we'd have negative 2, positive 6, negative 1, positive 5, 0. Oop. Miscalculated there. Let's redo that. So negative 2, positive 1, 2, 3, 4, 5, 6, which is up here. Negative 1, 5, which is there, 0, 4, 1, 3, and 2, 2. Okay, and then you just have to plot that. Now, let's go back and take a quick look at something. Did they give us a domain? No, because we picked the x's. When they give you a domain, you use the x's they give you. When they don't, you pick the x's. What that also means is that this is now a line. Okay, this goes on in either direction infinitely. So, you're going to kind of have to make the distinction between the two there. Okay? Couple things to remember. Always read the coordinates x first and then y. A few areas kids have problems sometimes also is the x-axis runs left and right. The y-axis runs up and down. Don't forget that. And then when you have to read a point from the graph, it's always easier if you find your x first, because you'll be less likely to make a mistake. Because if you find your x first, that'll be the first number you put down. All right, see you guys tomorrow. Hopefully you guys watch this so you're ready for the quiz. Thank you. Night.